Hello and welcome again to my Physics Online video lecture series. Today's video I'm going to be focusing a bit on how to use your computer to make graphs of your data, for example in Excel or in Libre Office. So basically using spreadsheet programs in general to make graphs of your data or to make plots of your data. And so this is really a video that is more for labs and lab activities than for lectures, although you can use it in lectures, especially if you're ever trying to plot data. For example, maybe you're doing some of the PhET simulations that are recommended either in your book or as pre-lecture activities or what have you, and you need to make a graph. So this will work for that as well. Most of this video is going to be taking place in Excel and or LibreOffice as time permits. But the basic process that we're looking at is we've kind of assumed that you have collected data already and you just need to somehow graph the data. So let's just go ahead and write the assumptions down here. Assumption: you already have collected your data. And so you just have a collection of data points, and you're just wanting to plot that. So you have all data points. And so basically what we're going to do is let's say basics of plotting, and then also how to use the linest function. So linearization and linest. Okay, so let's pull open an Excel sheet, and there will be sort of some data preloaded, and we'll just go from there. When you open up Excel, of course, you're often given a variety of options. For our purposes, a blank workbook is adequate. All right, so what you see here is sort of my preloaded data of X and of Y, and what we want to do is plot this data, or these data. So what we do is we basically are going to find a chart. All right, in Excel, this is under the Insert tab, and you come over here and find where it says Charts, and then what you really want is a scatter plot for most of our data. And so that will create something that looks like this, and then you need to select your data. And the way I like to do it is put them in series. You can name the series if there's going to be more than one of it, and then click on this arrow for select X values, and then just click and drag until you've highlighted all the X's, and then click on this box, and then you do likewise for all the Y values, and then click on the box. And what you have now is an X versus Y plot. It even gave it a title because it has no other title to give at the moment. Now to make this complete, you should be adding some axes titles, and then optionally you can add grid lines. You may need a legend if there's more than one set of data, and we'll talk about trend lines later, but not on this particular graph. So you give your axes a title by basically selecting those options. This is whatever X represents, and then whatever the units of X are. So it could be like, for example, a time in seconds. This right here is whatever Y represents, and then whatever the units of Y are should be in parentheses. So maybe it's a position in time, and so you'd say like meters on this axis and seconds on this one. Whatever you're plotting. And then this right here is the title, and it depends on what it is you're plotting again. Okay, so that's it. That's how you make a graph in Excel. Now, the thing is that you also need to go through a linearization procedure if the graph is not linear. And so to do that, you basically adjust your axes. And I'm going to create, in this case, a new axis, which is capital X, and that's just going to be the square of lowercase x. And so in Excel, if you're doing this, you hit the equals sign, you select the little X box or the little cell under X that you're wanting to square or square root or whatever. And since I'm squaring it, I put a caret 2, and that gives me 1 squared. And if I highlight all of these and then Control D, it will fill all of them in. So this is 1 squared, 2 squared, 3 squared, 4 squared, all the way down to 12 squared. Okay, so now what we want to do is make for ourselves another graph. And yes, we have to make a whole new graph in order to do this. And the reason why is because we've changed what our axes are in this graph. So again, select data. I always like to add a series so that stuff's in series so that we can do this. And I'm changing my x-axis to capital X. That's lowercase x squared. I am, however, in this case, leaving my y-axis alone. And so having done that, I can basically say this is all right. And if you look here, this now looks linear. And I'm going to go ahead and again add axis titles and a chart title. The chart might be something like linearization of x versus y. And then my axes titles, this one I could call capital X, but we know that what I really did was I squared lowercase x. So I'd say like lowercase x squared units of lowercase x also squared. And this axis title, I didn't change anything, so I would just call it y, and then again units of y. All right, so notice that up here I have a curve, and down here I have a straight line. So the next task is, since I've got for myself a straight line, I want to add to this a trend line. And I'm going to make it a linear trend line, like so. And I can basically select my linear trend line, and then this set of options appears. What I do is I come onto this, and I go ahead and click this box that says Display Equation on Chart. And the equation that I'm getting on this chart says y equals 0.5x plus 4. But this really just means whatever's on this axis and whatever's on this axis. So basically what I've done here, and this is these two things, I basically made a plot that had little y and little x on it, and I had something that was not linear. It was basically like doing something like this. And then I linearized it by replotting y versus capital X. And by linearizing it, basically I end up getting a nice straight line like this. The points actually kind of get farther apart as we go because of the operation I did. And so this right here ends up being a straight line. The straight line equation in this case has the form y equals some slope times big X plus b. Okay, so slope in this case, m, will look like delta of y over delta of big X. B, I just get by looking at where this intercepts. Although looking at the equation here, b in this case is 4 and m is 0.5. M and b both have units if these have units. B will have the same units as y. M will have the units of y over the units of x. In some sense, that's it for Excel. There's one last little thing that I want to include here, and that is the line estimate function. So line est, typed like this, L-I-N-E-S-T, parenthesis, it says known y's, comma, known x's. So I have to select my y values, put a comma, and select my x values. And then basically I like to make both of these things true. But you could actually close without making those both true. And when I do this, I get 0.5. Well, sure enough, that is the value of my slope. Before I close this out, I wanted to show what this same thing would look like in a different spreadsheet, which is the Libre Office spreadsheet, Calc. And I actually probably use Calc more than I use Excel, and that's just kind of a personal preference. So I've pasted here the same set of data, and what I'm going to do is I'm going to insert my chart. So I go to Insert, I look for Chart, I click Chart, and then it brings up this menu. And so I say it's going to be a data series. First I'm going to tell it that it's going to be a scatter plot. Then I'm going to give it the data series, and I just select the data series that I want. By the way, you do not have to highlight your data to do this in Libre Office. You can just go through it this way and select data like so. Okay, and then you click Next, and now it brings up the options for a chart title, subtitle, etc. And so we might call this like Y versus X plot or something like that. The x-axis, x, units of x. The y-axis, y, parentheses, units of y. Hit Finish, and you've got your chart. And so if you wanted to, again, replot the linearization, notice that I don't have anything selected. I'm just saying Chart. I go I make it a scatter chart, data series, add. You can give the series a name. I'm not going to because I don't need one at the moment. By default, it gives it the name of whatever column you've chosen. This time it's these is my x values. This time it's these is my y values. And then maybe linearization of y versus x. The x-axis is now, again, x squared, whatever the units of x are, squared. So you could even say like square of the units of x. And then this one right here is units of y. And for this one, in order to get your data points in here, so I'm going to delete this because I don't have multiple plots, but if you wanted multiple plots, you'd add another series. You'd keep that thing there because you want to have a legend. And to add your trend line, I am right-clicking. Whoops. You have to select the data, right-click, and then Insert Trend Line. And then, again, I want it to be linear. I want to show the equation. I don't really want it to extrapolate forward or backwards, but that basically just draws the line beyond the points. So right here is without the extrapolation forward or backwards. If I want to, let's say, extrapolate forward a few points, like so, now the line goes beyond this last data point. Okay, and so now I've got the linearization of this. The linest function is the same here as in Excel. What you do is you select your y values first, then you select your x values. And you can just do like that, and notice that this has given me 0.5, comma 4, 0.5, and 4. So this is my slope, this is my intercept. For what it's worth, I can actually add additional parts to it if I redo this array. And so equals linest, and then y's, comma, x's, comma, true, and then I think we do true here as well. and this is returning to me a bunch of regression statistics. Among other things, I'm getting here uncertainties in slope, uncertainties in intercept, and the r-squared value. So the r-squared value, as it turns out, is 1. The slope and intercept do not have any particular uncertainty to them because I've picked data that have a perfect straight line fit, hence the r-squared value is 1. Okay, so that's it in LibreOffice. All right, so that's it. That's all that I'm going to do in this video. And hopefully that is helpful to all of you who are trying to use Excel or even LibreOffice to plot your data for various labs and so on. So thanks for watching. Hope you learned what you needed to from this video, and see you in the next one.